Good morning everyone. Myself Harsh Patil, and today I am going to present on the topic visualization of vector fields and flow data, which is a part of computer graphics and visualization. In this presentation, I will first introduce visualization, then explain vector fields and different visualization techniques. After that, I'll cover flow data visualization, its types, and finally discuss applications, advantages, and limitations. The main goal of this topic is to understand how complex mathematical data like vector fields and flow data can be visually represented to analyze direction, magnitude, and movement in real-world systems. The objectives of this presentation are, first, to understand different techniques used to visualize vector fields such as glyphs, streamlines, and color mapping, and second, to analyze flow data using methods like pathlines and streaklines with real-world applications. Visualization is the process of converting complex data into graphical form so that it becomes easier to understand and analyze. It is widely used in fields like science, engineering, and simulations. In this topic, we mainly focus on vector fields and flow data. A vector field is a function that assigns a vector to every point in space. Each vector has two properties, magnitude and direction. For example, wind flow or magnetic fields can be represented as vector fields. To visualize vector fields, we use different techniques. The most common ones are arrow representation, streamlines, and color mapping. Each method helps us understand the data in a different way. Flow data represents how particles move over time in a vector field. It is time-dependent and is used in applications like weather prediction, fluid dynamics, and airflow analysis. There are three main ways to visualize flow data. Streamlines show the direction of flow at a particular instant. Pathlines show the actual path followed by a particle over time. Streaklines show particles passing through a fixed point. An important point is that in steady flow, all three are the same, but in unsteady flow, they are different. Vector field and flow visualization have many real-world applications. They are used in weather forecasting to study wind patterns, in aerodynamics for aircraft design, in oceanography for current analysis, and in medical fields to study blood flow. The advantages of visualization include better understanding of complex data, improved analysis, and support for simulations and decision-making in engineering and scientific fields. However, there are some limitations. Visualization can become cluttered when there is too much data. It also requires high computational power and proper scaling to represent data accurately. To summarize, vector fields represent magnitude and direction, while flow data represents movement over time. Different visualization techniques like glyphs, streamlines, and color mapping help in understanding these concepts. These methods are widely used in real-world applications. Thank you.